Hello. In previous video we will see how can you feed forward a neural network, what is neural network, what is the feed forward method, and how can you forward the input to the output, and then we get a prediction. First we take the input from the user, and for the each input we multiply with the connection corresponding weights, and then all the weights for the first hidden node we can add all the multiplications of two weights and x1 and x2 x3, we add all that, and then in last we add the bias term, and after adding that we apply the activation function based on your needs, ReLU, sigmoid or tanh. Then also we'll doing same thing for the node 2. If we have more nodes, we do same thing for the node 3 4, and we get the output, and then we do same thing for that corresponding to the connection, we multiply and we add those two, and in last we add the bias term, and we in the last we get prediction. And if they have more layer or they have more nodes, they are not, they are the same thing, we are doing the same thing and get the prediction. So now in the last video we see the prediction will not be right, because we will randomize all these value are random value, so there are no percentage that the prediction will be right. So after getting a wrong answer, how can I write the answer? So for that, this is called a supervised learning method. In supervised learning method, typically we getting data from the user, and also the answers mean labeled data. We take the labeled data. This is why labeled data, because with the data, and data is the corresponding questions, and we take the corresponding answer of that data. For that we call labeled data, because the answer also be join with them, and user will be given that. Then we uh, give we take a function called cost function equals to the prediction, means the y minus the original answer which is given by the user, whole square of all. This is called the cost function. So what is cost function? This is a fancy name or nothing, you can call it a function or anything. That is the prediction minus original output to the whole square. So here now it's come to derivative part. So what is derivative? In previous video I will told you that you have to know calculus. If you do not know, just go and see what is derivative. In derivative we have many rules, but we in gradient descent method, mean back propagate method, we need only two rules: chain rule and power rule. Chain rules, power rules mean if we have x to the power n as a function, we can, the derivative of that function is n into x to the power n minus 1. This is the derivative of that function. And if what is chain rule? If we have a function that is a function plus something or constant to the power whole square, then this is called chain rule. This, then we are applying chain rule on this function, because we have a under function on that. Then how can we apply chain function? We see that zx equals to x plus 2x. Now when we derivative the y respect to x, a parameter, which is a parameter is called the last output inputs or the last digits is called parameter. So here we are derivative the y respect to x. Now the derivative y respect to x is derivative of that under function. First we have to unpack this. So first we unpack this. So the unpack of this is derivative to the derivative of that by corresponding to the under function, respect to the under function. Why? Whenever we have any under function on a function, so we replace this x, the parameter, with that under function. So now we can replace the x with that under function zx. So we have to derivative the function respect to that under function, and then we have to unpack under function also. We are unpacking this, but we need to unpack this. So here the chain, this is called the chain rule. Now where we unpack this, and the parameter will be the functions parameter. So the zx parameter is x, so we are derivative that function respect to his parameter, so his parameter is x, and we are derivative the y respect to his parameter, and his parameter is zx. So we are done this, and now we are going to this. Now the parameter will be x. So now you can see, if we cancel zx, then we can get the same value dy by dx. The right hand and the left hand is same, so the mathematical perspective is also fulfilled. So now first we are unpacking the y by the power rule, because this is the square to the power, so we have to apply power rule. So power rule is n to into x to the power n minus 1. So here n is 2, so 2 into the x is whole function into to n to the power minus 1. Here n is 2 minus 1. Then we have to unpack the under function. So here the under function will be x plus 3x. So x will be the derivative to x respect to x is 1, derivative of anything respect to that is 1. So here 1 plus 2 into x is equal to 1 and 2 is 2, so here we get 3, and then derivative of that second. So the derivative of any constant is 0, so we are not write the 0 because the 3 will be 0, getting 0. So now how can we derivative? By using chain rule and power rule. You can visualize, you can see. Now if you not understand what I do, what I done in here, so probably for that you are not familiar with calculus, so you have to go on YouTube and search and see 3 blue 1 brown playlist essence of calculus, or reading any 12th standard book, then you will probably understand. And then we coming to the neural network propagation, back propagation part. How can we do the same thing by using derivative? How can we do back propagate of that neural network? So here we have the equation. What is the equation? So here just equation means the feed forward, all that outcome of each hidden layer node. So first node we have in first hidden layer we have two node 1 2, and the first node is y1, second is y2, and second out and the last output layer we have one prediction called y. So what is y1? Y1 is x1 w11 plus x2 w12 plus x3 w13. In previous video I will showing you how can we do all of this calculation, multiplication, addition. How can you do? If you do not understand, just go to the previous video and see that, then again come here, so we can know how can you do that. So this is the first h1. So what is h1 is the previous outcome before applying a sigmoid function. First we have do x1 into w11 plus x2 into w12 plus x3 into w13 plus x plus the bias term that will already feed it into that node, and that is equals to h1. Now we have to apply sigmoid function or any type of activation function to activate that node. Now what is the work of activation function? This is activation function. Scientists will see our human brain neuron will be activated in certain amount of power, in certain increasing factor. So by that they want to copy that model, so they also try to do same thing on artificial neurons. So they use a activation function called sigmoid. If you want to know about more about it, so just google it or youtube it, that what is activation function, why it's used in neural network. So then we have y2 same as that, and then we have last we have, if there are more nodes, so we can write, if there are more hidden layer, then we can write one by one by applying feed forward method. And in the last we have prediction y equals to the output of that node and output of that node, which is y1 y2 with corresponding their connection multiplication, and then add those elements is y1 into w31 plus y2 into w32 plus the bias which already feed it in that is equals to h, and applying activation function we got y is the prediction. So now we know what is the cost function. Cost function is the prediction minus original answers whole square. So this is means y minus y cap is the original answer to the of whole square of the total. So now how can we back propagate that, how can we update each parameter, because we have to change the each parameter, because the error here, the error means the wrong thing, mean this is the error, the answer minus prediction, which is the error, the subtract of these two is the error. So for each, if we change every parameter, then error also will be decreasing or increasing. Now how can we know that we have to increase the parameter or decrease the parameter? By derivative the cost function respect to that parameter. So first we have derivative cost function respect to first parameter, and then we apply chain function, then we apply power rule, and then we get a result which is called delta into that parameter, means the outcome is coming from coming from this parameters, but just it's showing on nothing. Now how can we update that parameter? By that parameter from subtracting the outcome from the original parameter, and by doing again and again that, not only for one parameter, we have to do for individual each every parameter, for w12 w13 w14, and for b1 b2 we have also have to do with biases, because biases also a parameter, this is also a category type of parameter. So we have to done it, we have to derivative of cost function respect to each and every parameter, which is called partial derivative. It's nothing but a fancy name, you can name it anything, it is called partial derivative. And after getting deltas of that parameter, we have to decrease that deltas from the original parameter, and we will update that, and this is called back propagate. Not only for the one question answer pair, we have to done it for every question answer pair, like that user if we did x1 x2 x3 x4 x2, like that he have feeded 10 questions and also 10 answers. So by doing we are done for this one time, we have to done for 10 times for every question we have to date. So we are done for each and every pair of question answer and back propagate that and decrease the derivative from the original parameter and update that, and again doing by that. But one thing we remember, we are not decrease subtract the delta directly by from the parameter. We have to take a learning rate. This is called learning rate. What is learning rate? Learning rate is nothing but a step. It's tell you how many step you take. Mean if our error is 2, so if our learning rate is 0.1, then we are not taking the whole error, we are taking only the small part of error, only the small part of total error. Why are we doing this? We know in this is a brief overview, we know this in depth part. So this is the more this is the all overview. And the learning rate are a specific number 0.001, or you have to change it in many number, and you have to test it that which learning rate is most suitable on your project or on your model. So by doing that, we have to, whenever we updating a parameter, for every parameter we have to multiply the learning rate with that deltas. So this is the brief overview of how to back propagate, how working, and how can I done this. Now if you want to know depth about it, how all this running by only derivative, how can we know that error will decreasing, what is error? So just focus on that video we are discussing now. And if you are not want to know about the whole depth things, you only want to work with that, then this is sufficient for you. Don't you have skip the video and over it. Now what are we doing by that? We taking every prediction, and we take the cost function and take that error and plot in a graph, and we see that all this error, every time we plotting the error, there have a minima. This is called global minima. So what is global minima? So this is the cost equation function, and error is we are taking for first error this, second for second training session this is errors, for third training session this error. And how can you plot? By x y coordinates. So we can plot all this, and this is the prediction line. So we see there only one minima. Minima means that line, that curve or that line or that plane will have a smallest value error, mean in there the error will be minimum, error will be minimum, so that is called global minimum. But whenever we have a line or we have a curve like that, so so there are certain possibilities that we are counting this minima, not that. So this but there, this minima is called local minima and this is global minima. The biggest minimum is called global minimum, and others minimum, this is also minimum, you can see by graph, this is also minimum but not the biggest, so this is called local minimums and this is called global minimum. And now the slope is a derivative, so slope is a derivative of that function, derivative of that function is called slope. Okay, so this is the slope, a point. Now if slope is positive, that means the point is increasing, the point error is increasing, and if the slope is negative means the point is decreasing. So now we take, why we take learning rate, we take learning rate because of, if we are here, if we are here and it's need only 0.1 step and our error is much more, then we can, so we are jumping this by here to here, so we are not getting here. So for that we have to multiply our learning rate, we have to multiply our learning rate, which is a very very smallest value, and for that smallest value the error will also be smallest, and then we take very short steps, and by that we do not jump the global minima, local minima. So why we'll use learning that, hope you understand. And the slope is, if you do not know what is slope, what is the direction, just go and see 3D geometry and derivative. All these things are related to derivative and 3D geometry. You have to understand linear algebra and derivative calculus, and then you will understand what I say. So this slope is the derivative of any equation. A slope is directing anything by a tangent, that if the slope is positive that means this is increasing, if increasing the error, and if the slope is negative in decreasing this error. And you hope you understand, this is the brief overview and with depth part.